Hi everybody. Today we are going to discuss about the PIC microcontroller, how the PIC microcontroller work, and where is the real time we can use for the PIC microcontroller. We can see one by one. So the PIC microcontroller first developed in the year of 1993 by General Instrument Microelectronics Division. The PIC microcontroller invention in the year of 1993, and mainly the microcontrollers are family of microcontrollers manufactured by the Microchip Technology. Mainly, the PIC microcontroller is always the expansion of Peripheral Interface Controller. It is called as PIC. We can understood for commonly the people can understand there's nothing but a programmable intelligent computer. Mainly the programmable intelligent computer. The simple PIC IC is called as a programmable intelligent computer mainly. The controller is widely used in various embedded systems because I already told it will be a very useful techniques and a very useful user friendly. We can use it in the anywhere. So it is a versatile instrument and it will be low cost and it can be used in anywhere. This is the main PIC microcontroller applications. And mainly this is a simple block diagram of PIC microcontroller is having the program ROMs, stack, and RAM, EPROM. These are all comes under the memory devices, and we have the CPU, central processing unit, and the program buses we have, and we have the data buses. In that we have this a field duplex mode. Mainly we can interconnect the other external peripheral devices like I/O ports, oscillator, timers, and other devices we can able to interconnect mainly. So these are all the PIC microcontroller simplified view how it will be interconnected. So everything is full duplex. Full duplex is simultaneously we can able to interconnect all the devices. That is called as a full duplex mode. So always the PIC microcontroller comes under the full duplex mode. So this is a simplified view of PIC microcontroller. Is having we are enter 808051 PIC microcontroller. We have 840 pins. We have in that the pin 0 to pin 40 we have VCC, ground, output port, input port, memory units, ground, reset port. Everything is available. So this is the simple view of PIC microcontroller. Mainly we have oscillator, CPU unit, and then external memory unit and program memory unit, RAMs, serial input output ports, IO lines, that is 32 IO ports available, and timer 1, timer 2 is available. So we have this simplified view, and we have the oscillator and the other input have the simplified view of input and output is possible, and other ways we have remaining things are the full duplex mode we are using here. And main characteristics. What are the main characteristics of the PIC microcontroller? Something about the architecture, instruction set, memory, and goes on. Mainly the architecture have the where we used in the memory and data and separate we can have the in PIC microcontroller, and also the simultaneous access of both instruction sets and the data we can able to access at a time. That is main use of the architecture. And the instruction set mainly the PIC microcontroller used to reduce the instructions, that is called as a reducer instruction set of computing we can use, and also use it in the typical results are more efficient to execute the program. And the main memory, that's the PIC microcontroller have the on-chip flash memory. We have the SRAM and the EEPRAM and E2PRAM we can use. By using the volatile and non-volatile memory also we can use here. And other characteristics of peripheral integration, low power consumption, and development of the tool we can use. The peripheral integration is nothing but we have that I2C, that is inter-integrated circuits, analog to digital converters, and serial peripheral interfaces we are using, and the UART, that is universal asynchronous receiver mode also we can use, and serial peripheral interface PA. These are the main peripheral interfaces we can controller mainly. So UART and I2C, ADC, the SCI are some special peripheral application integration we are using on the PIC microcontroller. The low power consumption may use in the PIC microcontroller we are designed to operate the low power and make them suitable for battery power consumption and main applications we are using the low power consumption. And the development tool, the microchip provide the comprehensive suite and development of the tools, PIC microcontroller, including the integrated development, that is IDEs, compilers, simulators, debuggers, and those facilities we can use for the main characteristics of the PIC microcontroller. So this is one example of PIC microcontroller. We have the laptop, we can program everything with the help of the flowchart, we can able to program it. That program is given to the PIC microcontroller devices. So we have executed here, we can program down. So likewise, we can execute everything, we can transmit the signal. So we simply give the instruction that microcontroller is executed the program by using this program circuit. So this is a simple way of example. And this is another main real-time applications. That's automatic light control. That's a traffic light control by using the PIC microcontroller. We have it's a program that the PIC 16F877A program we are using here, and we have the four-way track. So this is the electronic signals we can use. How we can use the signals here. So this is other methodologies of PIC microcontroller here. And the main applications of the PIC microcontroller is mainly the consumer electronics, industrial application, automation and automotive systems, medical devices, home appliances, IoT, robotics and embedded system and all main applications. So consumer electronics like a washing machine and our day-to-day life we are using the timer clock and everything we can use. So this is the industrial applications. We can as a production unit we can use the embedded microcontroller. This IO system we can able to interconnect link. So this is the timeline chip we can able to use, and then IoT things and the robotics and all we can use the real-time application of the PIC microcontroller. So this is another way of example, radio link and the 7-segment display, indicators, stepper motors, servo motors, LED, LCD displays, and the keypads and the potentiometers and the sensors and the computer peripheral devices, EEPROM. There's a main number of applications we are using the microcontroller in the day-to-day life. So this is another example analog to digital converter we are using that to explore the information from the circuits. So this is another application that is interfacing of microwave mobile with the Arduino, like it's a blink lit operator. So once you are blinking, so automatically will detect and how they are executing the sensoring and it will be executed here. So this is another memory of volatile and non-volatile memory. It's a temporary how it will be stored as integrated circuits in the electrically erased programmable. That is a non-volatile memory. And SSD is a flash chip also we can use in the PIC microcontroller. So this is another way of interfacing IO port. So this, imagine this is a chip we can able to interconnect and give the input of IO devices. This is a chip. This is a microcontroller block diagram. So we have the peripheral timers, SRAM, DRAMs, and the way references ports. We have a port to E port, and we have the reset port and memory unit. We have the yellow color, the one instruction set, one of the sets. This blue color is another instruction connectivity, and this pink color has another instruction sets. The CPU central processing unit is mainly the arithmetic logic unit, memory unit, and accumulator. Everything will be interconnected here, and processing will be done here. Thank you.